Okay, number 7, we want to find the complex zeros and then write f in factored form. So since it says complex zeros, I don't believe that we will be able to factor this guy by factor by grouping. So we're going to do find the possible rational zeros method. So I'm going to start out by finding the possible rational zeros. We're going to graph it to get rid of guess and check. We'll use synthetic division and then quadratic formula. So just recall x cubed minus 9x squared plus 31x minus 39. This guy is p. This guy up front was q. And we had to do p divided by q in all those factors. So we would do p divided by q, which is equal to 39 divided by 1. The factors of 39 are 1 and 39, 3 and 13. I think that's it. 1, 3, 13, and 39. All right, and then on the bottom, the only factor is 1. So we will take all of these numbers, divide them by 1, and remember positive or negative. So we have positive or negative 1, positive or negative 3, positive or negative 13, positive or negative 39. So this is 2, 4, 6, 8 numbers to try when you think positive or negative. A lot of work. So we're going to graph it. Go to y equal. Let me turn this on first. Go to y equal. I'm going to clear out what I have here, and I'm going to graph this polynomial. So we have x. I'm going to go ahead and get that cube, make it look nicer. X to the third power minus 9x squared plus 31x, and then minus 39. So I will either see it cross around 1 or 3, or if it crosses at 13 or 39, I will have to expand my window because my viewing window only goes out to 10. So let's graph and see what we see. So this line darkened, I have my window changed, so I need to change it back to standard. So I'm going to do zoom 6. Zoom 6 goes to standard. So you can see those tick marks. Okay, so that looks like it crosses 1, 2, 3, the third tick mark. So we're going to try positive 3 as our 0 to get us started. So we're going to do synthetic division. We need to look at our coefficients. That would be a 1, negative 9, 31, negative 39. We do have all of our terms, 3, 2, 1, 0, so we should be good to go. So the number we're going to be trying is 3, and coefficients would be 1, negative 9, 31, negative 39. Okay. So we bring the first term straight down. 3 times 1 is 3. We add or subtract. We get a negative 6. 3 times negative 6 will give us a negative 18. And then we would subtract these different signs, and that gives us 13. And then 3 times 13 is 39. And then that gets 0. So that's what we want. When we see 0 at the end, that means that this is a 0. All right, the problem wants us to write it in factored form. So I need to write this as a linear factor. So what 3 means is this. X equals 3. But when I solve and set it equal to 0, we get x minus 3 equals 0. This is one of the linear factors. Now, what do we do with the remaining part? We hadn't talked about that yet. So notice when we're doing synthetic division, we're actually dividing. We're dividing a factor of x minus 3 to be exact. When you divide off one of the powers of x, whatever you had, x to the third, you now reduce that power by 1. So now we're starting with x squared because we got rid of one of them with this when we did this process. So now these are the coefficients for my remaining polynomial. This number would be 1x squared. So and I'm going to count down in order. So this represents 1x squared. Since it's negative, it would be minus 6 and then x. You just drop that power down by 1. So 2, 1, 0. Since this is positive, it will be plus 13. Okay, so this is my remaining polynomial. Now that we have a quadratic, we can do quadratic formula. Okay, so I'm going to set that up. We're going to do negative b, which is going to be a positive 6, because it's opposite. Positive 6 plus or minus the square root b squared, so 6 squared is 36, minus 4 times a is 1, so that's just 4 times c, so 4 times 13, that's giving us 52. So we get a 52 here. So that is 4 times 1 times 13, 4ac. I'm just kind of doing it to condense because I'm running out of space here. So 4ac, all divided by 2a. 2 times 1, which is 2. All right, continuing, we get 6 plus or minus. When we do this math, we get 16, the square root of negative 16, that is, divided by 2. Negative under square root will give us imaginary, so I'm going to wrap around here. So we get 6 plus or minus imaginary square root of 16 divided by 2. Square root of 16 is equal to 4, so we get 6 plus or minus 4i divided by 2. And then we can divide each of these guys by 2. And that gives us 3 plus or minus 2i. So we have one linear factor at the top. We have one linear factor, which we came from x equals 3, and that gave us x minus 3 when we set it equal to 0. Now we have two more. X equals 3 plus 2i, and we also get x equals 3 minus 2i. When we move these terms over, this will become x minus 3 and then minus 2i. That is a linear complex factor. And when we move these over, we get x minus 3 plus 2i. So this would be our factored form of our polynomial with our complex zeros. So there's two parts. It says the complex zeros are. So these guys are my zeros. Okay, that is the 3, and then we have 3 plus 2i. Let me try to change that. Let me just do plus or minus to save me some space. So we can do that. And then the factored form. So it's going to be just putting all this together. X minus 3 and x minus 3 minus 2i, and then x minus 3 plus 2i.